In this video, we are moving on to the section of measurements, and we are going to specifically focus on surface area and volume. So before we move in grade 10, we get all kinds of cool shapes. But before we move to those, let's just check that we have a solid foundation. So we should, by now, know and understand how to work out the volume of these four basic prisms. A cylinder is technically not a prism, but these 3D figures, let's call them. Okay, so for a rectangular prism, to get the volume, that one's nice and easy. That's just length times breadth times height, okay? And so in any of these shapes, you've got length, breadth, and height there. And so if you multiply those three, that'll give you the volume. And then the surface area, sometimes total surface area is a nice abbreviation there, so TSA. What we need to understand is that this shape, if we were to unfold it, would kind of give us all the outer dimensions, and that's what surface area is. So the area of all the surfaces. So we've got this side here, and then on the other side of the shape would be a matching one. We've got the top of this box here, and on the bottom there would be a matching one, and we've got this small side here. Okay, and so generally we'll say it's 2 length times breadth plus 2 breadth times height plus 2 length times height. Okay, and there are a couple different versions of this. You could factorize out the 2, but as long as you understand that you're adding 2 of each face, then you're okay. All right, a cube, nice and straightforward. If we want the volume of a cube, that's literally side cubed. So a volume of a rectangular prism was length times breadth times height, but because a cube has the same dimensions for every side, you could say length times breadth times height, but you'd end up saying side times side times side when you substitute it in. And so that's a nice easy one, side cubed. And then in the same way, you've got 1, 2, 3, and then behind those, there's a face there, 4, 5, and 1 at the bottom, 6. So we've got 6 identical square faces, so total surface area is equal to 6 times the area of a square, which is just side times side, side squared. Okay, triangular based prism, what we need, this is called triangular based, even though if you were to picture it now, you'd say to me, oh, but it's resting on this rectangle here, that's what it's lying on. But basically, for something to have a base, the top and the bottom needs to be the same. So it's almost like we need to rotate this so that it stands on the triangle, because then the two faces across from each other are in fact the same. So what we do need to work out volume and surface area of a triangular based prism is something known here as the perpendicular height of that triangular base. Okay, now this, don't get confused, because a prism generally has an overall height. Let's call this capital H, an overall height, and then it has a triangular prism has this perpendicular height of the small triangle there. Okay, volume. Volume, I'm hoping you see the trend, is always the area of the base times the overall height of the shape. Okay, and so the area of a triangle is half base times height, that's the small perpendicular height, and then you multiply this by the overall height to give you the volume of this whole prism. Okay, and then surface area is going to be a little bit different, because we actually have got, if we were to unfold this, we'll have a triangle on this side, a rectangle on that side, a rectangle on this side, and a rectangle that it's lying on currently. So we'll have 3 rectangles and we'll have 2 triangles, and we need to just be able to work out the surface area of each of those. So we need a whole lot of side lengths in order to be able to make this work, but for the sake of having a formula, I'm just going to call it side 1, side 2, side 3. Okay, so in terms of total surface area, we've got 2 triangles, so 2 times a half base times height. Okay, base is essentially their side 1. And then we want to add all of the rectangles together and multiply them by the height. So the overall height, if we were to unfold this triangle here, the 3 sides would make one big rectangle. So I find it easiest just to go, it's the height times by the perimeter of that triangle there. Okay, and there are some great resources out there on the internet. If you don't have a good foundation of this from grade 8 to 9, go and have a look at how each of these shapes unfolds so that you walk into the grade 10 work with a greater understanding. Okay, what we can do here is 2 times a half. Those actually just end up multiplying to equal 1. So it's base times height plus the overall height multiplied by the perimeter there of the triangle. And that's how you get the total surface area of a triangular based prism. And then a cylinder, I've got to say a cylinder is one of my favorites because it's always so fascinating for me to think, if we take this edge here and we were to cut it open, we'd find that it would unfold into a rectangle with 2 little circles. And actually what happens is this here, this length here, is essentially the circumference of that circle that was the lid or the base of the cylinder. Okay, so we need to know again volume and surface area. Remember that volume again is just the area of the base times the overall height of the shape. Okay, and in terms of base, we need the length from the middle to the edge of a shape, which is called the radius. Okay, so volume of a circle is pi r squared, and then we multiply by the overall height of the prism there, or of the cylinder. And then surface area, I've shown you now with my little rough net drawing there. It's 2 circles, so total surface area is equal to 2. Now the area of a circle is pi r squared, plus, then we've got the area of this rectangle. And a rectangle's area is length times breadth. But remember, this here is essentially the circumference of the circle. So the length is now 2 pi r times by the height of the shape. So 2 pi r h. So that's how we work out the total surface area of a cylinder. Now you'll need to check with your teacher. Some teachers give you the formulas. Some teachers expect you to learn them. So make sure that you walk into an exam adequately prepared. But if you have my little trick about knowing that volume is always the area of the base, length times breadth, times the height of the shape, and then surface area you can essentially work out if you can just picture how you would unfold any given shape, and then you can work out the area of all of the faces that make up that shape. So you will be able to calculate any of these if they are asked. Okay, generally at grade 10 level, they don't get asked as a single shape. They like to combine them. So here's a little house that I've drawn for us. And if we look at it, we'll see 2 shapes make up this house. We have this rectangular prism that forms the base, and then a triangular base prism that forms the roof. Okay, and they've asked us here for the volume of this shape. All right, so volume, generally area of the base times the overall height of the shape. Now, once again, we just need to break this up into 2, and then we need to remember volume is the area of the base times by the overall height of the shape. Okay, let's start with that rectangular base prism. So volume of shape 1, I like to call it, is just going to be length times breadth times height. And then we can fill in. The length is 20, the breadth is 18, the height is 14. And that gives us an answer of 5,040 centimeters cubed. Remember, volume is always cubic units. And then we need the volume of this shape on top, okay? And so that's a triangular based prism. And so even though, like I said earlier, it's resting on a rectangle, the base has to be a triangle because the base and the lid of a shape need to be identical across from each other in order to make a prism. Okay, so we're going to use the triangle as our base. So what's the area of a triangle? It's half base times height. And then once we have the area of the base, we times by the overall height of the shape. Okay, so looking at this here, the overall height of this triangular prism is actually the same as the length there of our rectangle. So 20 centimeters is the height of the shape. Okay, now we're going to work out the triangle. Half of the base side here is 18 centimeters. So half of 18 will give us, well, if we've written the half, then we just keep it like that. Otherwise, we need to work out half of 18, and then we just write 9 instead of that whole calculation. Okay, times by the height of this, which is 12. So times by 12, times by the overall height, which is 20. So that gives us a volume of 2,160 cubic centimeters. And so then we can say, therefore, the total volume of this shape is equal to, and then we add these two answers together because it's a composite shape. And that gives us an answer of 7,200 centimeters cubed. Now, what they love to ask us is to say, okay, well, if this is the volume in centimeters cubed, what is the volume in meters cubed or in kilometers cubed? And so it's important for us to know how to do conversions and apply what is known as scale factor. Now, when it comes to converting units, I always find this a very helpful tool. So what you do is you write your units from smallest to biggest, so millimeters, centimeters, meters, and kilometers, and then you write 1, 2, 3 zeros over there. Okay, and essentially what these represent is groups of 10. So here we'd multiply by 10, here we'd multiply by 100, here we'd multiply by 1,000. Let's look at some examples so we can test out this method. So if they say to us convert 1 million millimeters to centimeters, one other thing that we need to know before we can use this method is that if we go from millimeters to kilometers, we are going to divide, and if we go from kilometers to millimeters, we are going to times, or anything in that direction. So here in the example, they want 1 million millimeters to centimeters. There is 1 0 here. Okay, and I'm going in the divide direction, so what I want to do there is divide by 10. So 1 million divided by 10 gives me 100,000 centimeters. But what happens if I get asked to convert all the way from millimeters to kilometers? So now what I'm doing is I'm going from here, still in the divide direction, but 1, 2, 3, 4, 5, 6 zeros. So what I need to do is I need to take my 1 million and divide by 1 and 6 zeros. So essentially I'm dividing by 1 million, and so that is going to take me all the way to 1 kilometer. So this method is pretty straightforward, and what is also helpful about it is that it helps us when we work with square and cubic units. So let's say they asked us to convert from 3 kilometers squared to centimeters squared. So kilometers is over here, centimeters is over here. So I'm going to move in the multiplication direction. So what I would ordinarily do, if these were just straightforward units, is I would take 3 and I would times it by 1 and 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5, 100,000. And that would normally work. But this is squared. These units here are squared. And so instead of multiplying by 100,000, we need to multiply by 100,000 squared. So I'm basically going to be hopping the comma, if you remember multiplying by 10 like that, 5 places and another 5 places. So we're going to end up with 30 million centimeters squared if we were asked to convert that. It's very similar when we work with cubic units. So if I need to go from meters cubed to centimeters cubed, I'm going in the multiplication direction, and ordinarily there would be 2 zeros. So I would usually go 0,05 times by 1 and 2 zeros, but it's cubed. So I actually need to multiply by 100 and 100 and 100. Okay, so I need to multiply by 6 zeros in the end. Or technically a 1 and 6 zeros in the end. Or if you want to think about hopping the comma, you would take it from where it is and you would hop 1, 2, 3, 4, 5, 6 places to get from meters to centimeters. And so that leaves us here at 50,000 centimeters cubed. Something that they like to ask us is a thing called scale factor. So scale factor is when we adjust the dimensions of one or more of the sides of our shape, and that has an impact on the surface area and the volume of that shape. Now, most of the time, scale factor is represented by a variable of k. So if k is anything bigger than 1, then our shape is going to enlarge. And if k is a fraction, okay, and the mathematical way of writing that would be between 0 and 1, then if k is sort of a smaller number, then we are going to see a reduction in the shape that we are dealing with. All right, so they might say to you, okay, this entire shape here is enlarged by a scale factor of 3. What is the new surface area and the new volume? So for the sake of time, I've just worked out, based on the formulas we looked at right at the beginning of this video, the surface area and the volume of this shape. And so now, because of the scale factor knowledge, we can actually just straight away say, okay, well, if the scale factor is equal to 3, we will have a new surface area. Okay, and surface area has a square dimension. So we'll take our 104 and we'll times it by the scale factor squared. Why? Area is always in square units. And if we needed the volume, we would take our scale factor. So we've got our original volume there, multiply by the scale factor, and volume is always cubed. So the scale factor will be cubed. So popping that onto my calculator, all that I do is I take the surface area I had, multiplied by the scale factor squared, because area is squared, gives me 936 meters squared, and I take the volume that I had, multiplied by the scale factor cubed, gives me 1,296 meters cubed. And so if you understand the fact that surface area is always square units and volume is always cubic units, then you can very much apply the fact that you can multiply by the scale factor either squared or cubed, depending on what you're working with. And then just read your question very carefully, because every now and again they like to get us thinking, and they say, what happens if we only change one of the dimensions? Okay, then we can't cube the scale factor, because technically not all 3, it's not length, breadth and height being changed. So then we just multiply by 3. But the key to measurement and maths in general is to keep on practicing, because you get very good at training your brain to understand these questions. And so the more you practice, the better you will grasp this concept.